Hi students, good morning students. In previous video I explained a Bohr model, hydrogen spectrum, and now observed here different PYQ questions from the structure of atom, Bohr model based. Question number 27, observe that what is given here. The energy of electron in the first Bohr orbit of hydrogen atom minus 13.6 electron volts. The magnitude of energy value of electron in the first excited state of beryllium 3 plus is dash electron volts. Integer based question is asked here. Energy of the nth orbit formula, you know that, minus 13.6 into Z square by N square electron volt per atom. This is energy of electron in the nth orbit. First orbit energy E1 is equal to minus 13.6 into Z square value 1 hydrogen atom, orbit number 1 electron volt per atom. So what is that value? Minus 13.6 electron volt per atom. This is the energy of electron in the first orbit of hydrogen atom. The magnitude of energy of electron in the first excited state. Here in the hydrogen spectrum, n is equal to 1, that is first orbit. N is equal to 2, that is second orbit. N equal to 3, that is third orbit. Electron is moving from here to here, that is excited state. This is first excited state. Electron is moving from ground level to third orbit, that is second excited state. Here first excited state means what is the orbit? First excited state means what is the orbit here? Second orbit. So n value here the 2. N value 2. Atomic number, what is given? Atomic number beryllium 3 plus is given. So n value 2. Beryllium atomic number 4. Beryllium 3 plus. So E2 is equal to minus 13.6 into Z square value 4 square by N square value 2 square. So minus 13.6 into 4. How much? Electron volt per atom value minus 54 point something value you are getting. 4 electron volts per atom. Answer is this one, 54. Nearest integer answer. Yeah, students, observe the next question, students. Which of the following postulates of Bohr model of hydrogen atom is not in agreement with quantum mechanical model of atom, Schrodinger wave equation? So what is the contradiction is existing? What is the difference between Bohr model and quantum mechanical model? An atom in a stationary state does not emit electromagnetic radiation as long as it stays in the same state. Both the theories point of view, Bohr model theory, quantum mechanical model theory, this statement is correct na? Stationary state means electron energy is same. An atom can take only certain distinct energies E1, E2, E3. These allowed states are simply called as stationary states. Energy of the electron in those states remains constant, both Bohr model as well as quantum mechanical model. When electron makes a transition from higher energy state to lower energy state, that is emission. Na? Already in the Bohr hydrogen spectrum, emission spectrum we discussed. Electron is moving from higher orbit to lower orbit. Higher orbit to lower orbit, emission of spectrum. Electron is moving from lower orbit to higher orbit, absorption spectrum. Next option D, observe that electron in a hydrogen atom stationary state moves in a circle around the nucleus. That statement is not agreement. Bohr model and quantum mechanical model explanation is different. Here, according to Bohr model, electron is revolving around the nucleus like a circular path. Bohr gave his explanation like this. But quantum mechanical model, electron is revolving not a circular path, it is revolving like a three-dimensional arrangement. Electron movement around the nucleus like 3D arrangement. The position of the electron is not fixed. It is revolving like a wave motion. For example, de Broglie is the wave. This is the wave of de Broglie. Around the nucleus, electron is revolving like a wave. the position of the electron is not remains same everywhere. 3D arrangement. Electron revolving is 3D arrangement. The next question observed here, students. For hydrogen-like species, which of the following graphs provides the most appropriate representation E versus Z plot for a constant N? Simply, you know that already, students. Energy formula, nth orbit energy formula. What is the nth orbit energy formula? En is equal to minus 13.6 into Z square by N square. Electron volt per atom. Electron volt per atom. So here Z value increases, energy decreases because of sign is negative, sign is present. On the x-axis, on the y-axis, this is x-axis, I am taking Z atomic number, on the y-axis E energy. Here the energy is 0 and here the positive, here the negative is present. So atomic number increases, energy what happens here? Decreases. Energy, nth orbit energy decreases with increase in atomic number as per the equation. Energy increases with increasing orbit number as per the equation based on the sign. So here the relation is existing between E and Z value like this. Linear decreasing not existing. The curve is present like this based on the energy values. This curve is comes from the based on the energy values with the different orbits and different atomic numbers. Okay. Option B is the correct option. Next question observe here, students. Heat treatment for muscular pain involves radiation of wavelength of about 900 nanometers. Which spectral line of hydrogen atom is suitable for this? For muscular pain, one of the spectral line is using which spectral line? Based on the data, identify that. Wavelength, how much is given? 900 nanometers are given. 1 nanometer is equal to how many centimeters? 900 into 10 power minus 7 centimeters. So I am writing this relation 9 into 10 power minus 5 centimeters. Correct na? Lambda is equal to 9 into 10 power minus 5 centimeters. Rydberg equation formula 1 by lambda is equal to RH Z square 1 by N1 square minus 1 by N2 square. This is the Rydberg equation formula. Already you have an idea. So lambda value we know that RH value already is given in the question 10 power 5 centimeter inverse. So RH I am taking this side 1 by lambda into RH. Z value that is a hydrogen atom na, hydrogen atomic number 1. So that is simply 1 by N1 square minus 1 by N2 square. This is the relation. So 1 by lambda value how much? 9 into 10 power minus 5 centimeters. And RH value how much? How much is given? 10 power 5. 10 power 5 centimeter inverse is equal to 1 by N1 square minus 1 by N2 square. 10 power 5 get cancelled. How much is remaining? 1 by 9 is remaining. Is equal to 1 by N1 square minus 1 by N2 square. So this relation almost it is related with 1 by 3 square minus 1 by infinite square. 1 by infinite square is nothing but 0 na. 1 by infinite value is 0. So 1 by 9 is equal to n value here 3. N1 value is 3, N2 value is infinite. So option is the which option? Infinity to 3. So option is option A, first option. Next question observe here, students. Radius of first excited state of helium ion is given as radius of first excited state. What is the radius formula? First of all, radius of nth orbit formula 0.529 n square by z angstroms. We know that already. Radius of first orbit formula. Radius of first orbit of hydrogen atom, how much is given? A naught. That is equal to 0.529 5 to 9. So this value substitute here, Rn is equal to A naught n square by Z angstroms. Helium is asking, first excited state means n value 2. Helium atomic number, Z value 2. So R2 is equal to A naught 2 square by 2. 2A naught. Answer is 2A naught. 2 get cancelled, 2A naught. So option is D option.